Okay, so we are going to be looking at completing this square today, and we're going to use some algebra tiles. And I don't know that I do this exactly like other people do, but we're going to use this part of the little algebra tile thingy today. And we'll just talk a little bit about the tiles first. Your square tiles, I'm using yellow. This is actually an x squared. We're not going to write on all of them, although you could with an expo marker. It wouldn't hurt anything. But this represents an x squared. And it's a square. So, hello, it actually makes sense. I know, crazy. These little bars are x's, and that's because they're x in width and they're 1 in length. And then these little pieces, got some towers being built here. These little pieces are actually just units. So this is like 1, 2, 3. So these would represent the regular numbers. My little green, they're just basically like centimeter cubes. And so what we're going to do is see how to take an expression and complete the square. And I'm going to admit right now I'm not really sure where this activity came from off the internet. If somebody wants to take credit for this in the comments, that would be fine. So we're going to complete the square using algebra tiles. And so we're going to use algebra tiles to find the value of c that would make the expression x squared plus 6x plus c a perfect square trinomial. So part A says use algebra tiles to model the expression x squared plus 6x. So what we're going to do is I need an x squared tile, which I have, and then I need 6 x tiles. So there's 2, there's 3, and then what you want to do is divide them up. Oh, actually, I'll just start this way. We'll start this way and we'll divide them up in a second. I don't have all of them marked as x, but those are x tiles. So this would be x squared plus 6x. And what they want us to do is what's called completing the square. They want us to make a big square using these and figure out how many little green cubes I would need. So the trick is, here's the trick, is we take half of the x tiles, we're going to take half, and move them down here. And I'm gonna use this little tool here just to line everything up. So I've got 6 x tiles. I put half of them on this side and half of them on this side. Because if you have a square, you want to make them the same, right? Length and width the same. And what's asking us is how many little unit tiles, so these, is it going to take to complete the square? So we're literally just using little hands-on things to make a square, and it represents a big algebra concept. One that we'll use this year, and I also use it a lot senior year when we do some pre-calculus things. So we'll put this in here like this, and you can see that it's 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Not all of my little unit squares are quite the same color, but that's okay. So I have x squared plus 6x, and then I need 9 little unit tiles to complete the square. So on our little worksheet, I actually just did some of this. And so down on part C it says, let me find a pencil that actually works. It says determine how many unit tiles are needed to complete the square. Add the unit tiles to your arrangement. You now have a perfect square trinomial. So we added 6 units to it. So that was the first part. And it's a perfect square trinomial. So let me explain what that means. What this means is I have this, since this is x squared, the sides are x times x. This is x plus 1, 2, 3 this way. This is x plus 1, 2, 3 this way. And you can actually model this on the other side of your plus sign. I hope you guys have enough of these. So let me show you with the tiles. what this looks like. So what I'm actually doing in this picture, if I can get all of these on here, I do have opposable thumbs. I do. They work sometimes. I'm multiplying x plus 3 times x plus 3 to get this whole thing. And so what we did is we just modeled x plus 3 squared. And it's kind of a weird idea. You're not going to quite get it yet. That's okay. We're just kind of playing. But our perfect square trinomial, grab the right thing, this right here is x plus 3 squared. That's what we just made by adding the 6 units on. So what we're trying to do algebraically is make these into perfect squares. So if I was factoring them, you would get the same thing twice. And there's some really useful things with this if we start getting into some analytical geometry stuff. All right, so it says find the length and width of your rectangle, how you factored, does it say much? How you factored expressions using algebra tiles, write the product of the length and width. Okay, so I kind of did this up there. Oops. The teacher needs to read the directions. I kind of skipped ahead. So what we're going to do now is just make some more squares. So on number 2, it says use algebra tiles to find the value of C for each of the expressions in the table, and then write the expression as a squared binomial. So on this first one, it says we're doing x squared plus 6x plus c. So we'll just write in the information. We used 6 unit tiles, and we got x plus 3 squared. So we'll do the next 3, and we're going to look for some patterns that's going to help us with the next lesson. So the next one just has x squared plus 2x. So I'm going to take a bunch away. Just kind of scattered those off. So I'm just going to have x squared plus 2x's. And I want to put 1 here and 1 here. How many little units am I going to need to make this square? Not very many, right? There's just the one little hole. I'm going to put one little measly cube in there, and that's it. And so we added on the worksheet 1 unit tile. And then if we're going to look at what it is squared, we can figure that out this way. So this would be x plus 1. And this way, it is x plus 1. So that's your length and your width. So it's actually x plus 1 squared. We also could figure this out by just rewriting this as x squared plus 2x plus 1 and thinking about how we would have factored that. So we would have drawn our little x. I'll do this over here, and it multiplies to make 1 and adds to get 2, and you'd have 1 and 1. And we would have factored it as x plus 1, x plus 1. And so this is related to what we just did. Okay. I know, fun, kind of. So let's look at the next one. We're going to have x squared plus 4x. So now I'm going to need 2 on this side and 2 on this side to make 4. I'm just going to pull these away so we can focus on what we have right here. And so if I have 1, 2, 3, 4 x's, how many little cubes am I going to need? How many units?
The one you need to add.
The one, I need to add 3 more, yes. So I'm just total, it will be 4. So I have 4 in there. And then if I want to see what the perfect square is, let me get this all on the screen, then I would have x plus 2 on each side. So if I go over here, we added 4. So that means it is x squared plus 4x plus 4. I'm trying to write with the tiles underneath. That did not work. There we go. And so basically what we're doing is factoring it, but I'm using the tiles to kind of model what it's factored to be. So x plus 2 and x plus 2, and so then this would be x plus 2 squared. So you can see it with the little tiles. You could also go back to how we did factoring trinomials in the last unit, but I want it to kind of make sense visually. All right, so the next one, I need x squared plus 8x. So move these away. I'm going to need 8 of these little bars. Let's see if I have that many. There's 4, and here's 8. So that's going to require quite a few of the little cubes. So I've got 4 in there. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. A lot of little cubes. So we added 16. And then if we look at what this would be length and width-wise, like what are we actually multiplying to get this? I'm going to have x plus, let me grab a bunch of cubes, x plus 4 this way. And then this is x plus 4 this way. Ta-da! And yeah, I think that's the biggest one we're going to do. And so I'm going to write it before I stick it up there. We added 16 units. And so what that means is we just made this into x squared plus 8x plus 16. And it factors to x plus 4 squared, which you can see visually. And you can also just think about factoring this. So it multiplies to get 16 and adds to make 8. Well, it's 4. So now we're going to look for a relationship. What's the relationship between the value of c and the coefficient of x for each expression? So they want to know a relationship between this number and this number that was already in there. So we're looking at... oh, you know what? I wrote this wrong. This should have been 9. I wrote a 6. It was an upside down 6. I'm just gifted. So they want us to look at the relationship between this number. So in this case, it would be the 6 with the 6x and the 9, the 2 with the 2x and 1, the 4 with the 4x and this 4, and the 8 with this and the 16. And there's a clue into how we did this process. So let me kind of walk you through that. When we went to do the first problem, we had all of these x's just lined up this way. And the first thing that I told you to do with them was to split them in half. We divided them in half. A way to say that with math is that we divided that number by 2. So I took 8 and divided by 2 and got 4. So I'm going to write this down on the paper just to keep track under this. So I took 8 divided by 2 and I got 4. And then somehow I'm going from 4 to the 16. So if we look at that, when I start putting in the tiles, I have to have 4 this way. I also have to have 4 this way, and we're filling it in, so we're taking 4 times 4. And it's always the same number times itself because we're trying to make a square. And so what I just did was I took 4, which is one of these sides, and I squared it. So I took the 8, divided by 2, got 4, and then I squared it. And so to get the 16, you do 4 squared, 16. That's where this number is coming from. So your process is divide by 2 and square the answer. So that's what we're going to write down here. So we're going to divide by 2 and then square the answer to get C, which is that last number.
Yeah, that's right.
I'm off the screen. So let me move this up. I got to have my students to keep me in check. So divide by 2, square the answer to get C. That's basically what we just did. And it's easy to understand why when you see the picture. So it says, therefore, how could you find the value of C directly when completing the square for any quadratic trinomial in the form x squared plus bx plus c? So we're just going to write it out. You're going to take b and divide it by 2. And then you square the answer. So I could just put this in parentheses and square it, and that's how you're going to get C every time. So let me give you a crazy example. If I had x squared plus 50x, and we're trying to figure out what value of C this is, I'm not going to want to do the tiles with 50 x's and then have to fill it in. It's a little bit bigger problem. It'd be a little messy to count. But now that I've found this relationship, what I can do is just take this 50, and my steps are first to divide by 2, which gives me 25, and then I'm going to square 25. So 25 times 25, we get 625. And so then this C, the number that I need, is 625. And I can write that as x plus 25 squared, which is the number that comes from here. And we're going to use that a lot in the next lesson and a whole bunch later. Okay.